Okay, I will start our meeting today by example number 2 for our new module number 6. I know I didn't cover some in previous week. I will go through them just few minutes later. So I will start with example number 2. This example looks like that one in your coming exam. We have a beam. This beam is supporting dead load 0.2 kb per foot and the live load 0.3 kb per foot. The beam is fixed at A, so A is fixed. Roller at C, and B is a pin connection. Okay, I understand that we have fixed, we have roller, we have pin connection, but I cannot understand what is the meaning of dead load and live load. Okay, never mind. The first step, we need to draw influence lines for reaction. Yeah, I understand this step. Draw influence lines for reaction. Actually, for this beam, we have fixed, so we have vertical reaction YA, and we have moment would like to make this member to smile MA. What about XA? We don't care about any horizontal reaction. For influence line, this support is roller C, so we have vertical reaction YC. Let's start to draw influence line for reaction YA, influence line for reaction MA, influence line for reaction YC. Guys, remember, I will not say, please draw influence line for YA, MA, YC. No, I will not say this. I will ask you to draw influence line for reactions. So please be familiar. What reactions do you have? We have fixed, we have two reactions, one vertical and a moment. We have roller, we have one reaction, one vertical. Okay, just a reminder. Do you remember if you have beam fixed at one end and you would like to draw influence line for the vertical reaction, we need to move, keep, and deform shape. Move this support up by 1. I believe if you move a fixed support up by 1, the whole beam, I'm sorry, not the whole beam, the whole part attached to this fixed will move up by 1. Do you agree for this? Do you agree? So I will move this support up by 1. If you move this support up by 1, the whole part, this part only, which is attached to this fixed, will move up by 1. If you have pin connection like this one, and this side moved up, the other side must move up with the same level. So I forget something. If you push support A up by 1, any other support will remain without movement. So C will remain as it is. This side of the connection moved up. The other side of the connection must follow it. So this side will be up. So the new shape of this part of the beam looks like this. Positive, negative, this value is 1. Anybody can tell me what is the value here? I mentioned the last meeting, if you would like to get a value at any point, use triangle similarity. So we have this triangle looks like this one. I believe this distance equal to this distance, so this value will equal to this one will be 1. influence line for moment. Just a reminder. Last meeting, I told you if you have a part supported by this fixed, so the assumed moment would like to make this bar to smile. So this is MA. If you would like to draw influence line for MA, go ahead and rotate this fixed in the same direction of this moment by theta angle theta equal 1. I think the new shape of this beam looks like this. So this is the case. If you would like to draw influence line for MA, I would like to rotate this fixed by angle theta equal 1. Why in this direction? Because my moment in this direction. Why you assumed this moment in this direction? Because this direction will make this bar to smile. So the new shape of this part will be looks like this. Just to give you a hint, this angle theta equal 1 equal to this angle theta equal 1. Tan theta equal 1. Because theta is very small, I can assume tan theta equal theta. So tan theta equal the opposite divide adjacent. So tan theta equal opposite divide adjacent. What do you like to say? I would like to say, if this length of the part equal 10 feet, this length equal 10 feet, I believe this value will be 10. You know why? Because tan theta equal 1. So if the adjacent is 10 feet, the opposite will be 10, because 10 divided 10 equal 1. What do you mean? I mean this value will be 10. In a very simple word, when you would like to draw influence line for a moment at fixed, this length of the part will equal this value of the influence line. And I told you why. Because this angle theta equal 1 equal to this rotation equal 1. Because this angle is very small, so tan theta equal 1. Tan theta equal opposite divide adjacent. The adjacent is 10 feet, so the opposite will be 10 feet. If you divide 10 by 10, you will have 1. Anyway, any other support, no movement. Because this side of the connection moved down by 10, the other side will move down by 10. So the new shape of this part looks like this. This side is negative, this side is positive. I believe this value is 10. This one will be 10 also, because we have triangle similarity. Guys, to explain it, this value is 10. This value will be 10. Why? Because this distance is 10 feet. This distance is 10 feet. So if you make triangle similarity between this triangle and this triangle, I can say this side divide this side equal to this value divide this value. I will find this one will be 10. Anyway, the last one, influence line for reaction YC. Push support C up by 1. Any other support, no movement. Just a reminder, last meeting I told you, if you have fixed support and one part of the beam attached to this fixed support, if you didn't move this fixed, the whole part will not move. So in this case, I didn't move this fixed. So the whole part attached to this fixed will not move. If this part didn't move, the other side of the connection will not move. So the new position of this part looks like this. I believe this value will be 2. If you do triangle similarity, this value will be 2, because this value is 1 and this value is 0. This is the influence line for reaction YC, influence line for moment MA, influence line for reaction YA. Anybody has any question? Guys, do you have any question related to this reaction? Okay. So I am done with the first part. I am done with the first part. To go through the second part, calculate the maximum negative moment at A and the maximum positive reaction at C, we need to understand what is the meaning of dead load is given, what is the meaning of live load. So to do this, I have to go back to the previous week module. Assume we are talking about influence line of YA. It's the same problem. YA looks like this. Negative, positive. So we have dead load and we have live load, and we need to figure out the maximum effect. Let me explain it here first before going through the example. Anybody knows what is the meaning of dead load? Because if you don't understand what is the meaning of dead load, you will not understand what is the effect. Anybody can tell me what is the meaning of dead load and what is the meaning of live load? It's very important to understand what is the concept of these types of load. Anybody, I need answer. Anybody can tell me what is the meaning of dead load? So this load is dead or died last week, or this load, the live load, is still alive. What do you mean by dead load and live load? Any answer? Live load can move. Okay, good answer. Load that does not move, you mean dead load. Miguel, I think. Yes, okay. Dead load is the load of the structure itself. It's a good point. Dead load is the load of the structure itself. It's a good point. Okay, let me say something. Dead load can be called own weight of the structure. So if you go to buy some tomato from Walmart, the tomato you are buying has a weight, 1 pound, 2 pound, 3 pound. So any structure, any element in this world has a weight. So the own weight of the structure can be called dead load. I have another question. You are a person has own weight. You have a weight, 200 pound, 150, 250 pound. So you have a weight. Let me ask you a question because it's very important. Can you go to campus? If I would like to ask you, hey, can you meet me on campus? And please, can you leave your weight at home? Does it make sense? If I ask you to meet me on campus and I'm asking, please, can you leave your weight at home? Does it make sense? Can you leave your own weight at home and you are going to campus or meeting someone? No way. When, or I'm sorry, where you are, your own weight is it? It's there. That makes sense? So no way to leave own weight at any place. where you are, your weight is there. So for dead load, we don't have a choice, because dead load must cover the whole structure. I'm sorry, what you mean? I mean, if you are talking about dead load, I'm talking about weight of the structure. If you are talking about weight of the structure, must cover the whole structure. I cannot move or leave on weight at a point and move it to another point. So no way for dead load, the value of dead load must cover the whole beam. We don't have a choice. So if your dead load, for example, 0.2 kb per foot, so we have uniform distributed load covering the whole structure, the whole beam. No choice. I cannot put dead load at specific location and remove it from another. Your dead load must cover the whole beam. Do you know why? I explained it. Because dead load means weight of the structure. If you have a structure, you must have weight. And the weight of any body cannot leave the body. So, for our example, if you would like to calculate the maximum negative moment at A or maximum positive reaction at C, I don't care about negative or positive. If you are talking about dead load, we don't have a choice. Your dead load must cover the whole beam. That makes sense? So no choice means you don't need to think about anything. If you have dead load, okay, go ahead and put your dead load covering the whole beam. But for life load, we are life load. We are life load. What you mean by we are life load? Okay, try to think about your family in your apartment. Sometimes in the evening, you are sitting, all of your family, sitting in the living room. Few minutes later, all of you can sit in the kitchen to take dinner. So you are moving from one side to another side, from one area to another area in your apartment, because you are life load. So life load can move. Life load looks like trucks. Your trucks can be at the beginning of the bridge, few seconds later at the middle of the bridge, few minutes later at the end of the bridge. So life load can move. Can you tell me where can I put life load to get maximum positive effect? It's very easy. At this time, we need to look to YA. Where is the positive diagram of YA? I think the positive diagram from this point C to this point A. Okay, go ahead and put life load at this location only. If you put life load at this location only, believe me, this position of life load can give you maximum positive effect. Okay, can you tell me where can I put the life load to get the maximum negative effect of YA? Okay, go ahead and look to YA. Where is the negative diagram or the negative part of diagram YA? I think the negative part from C to D. Here is the negative part of this diagram. Okay, go ahead and put the live load at this location. Believe me, if you have a bridge and you put the live load on this part only, you are going to get the maximum negative effect on reaction YE. So for live load, you can put this load anywhere as you like to make the maximum effect. If you would like to get maximum positive effect, okay, go ahead and look to the diagram, and where is the positive part of this diagram, and put your live load only under this part of the diagram. Then you can get the maximum positive. The same for maximum negative. Is it clear? Do you have any question for this point? We learned what is the difference between dead load and live load. Dead load, we don't have choice. The dead load must cover the whole beam, whatever the diagram, whatever. You have positive, you have negative, you have anything. I don't have a choice for dead load because dead load represents the own weight of the structure. So the dead load must cover the whole beam. For live load, we have a choice. You need to ask yourself, do you need maximum positive? So I have to put the live load under the positive diagram only. If you would like to get the maximum negative, I have to put this live load under the negative diagram only. For live load, we don't have something called maximum and that's it. No, you have to say maximum positive or maximum negative. Looks good? Okay, let me go back to our example. We need to get the maximum negative moment at A. Can you remind me what is the influence line of MA? Influence line for MA looks like this. 10, positive, negative. Influence line for MA was like this. Can you tell me how can I figure out the maximum negative moment at A? Okay. What about the dead load? What about the live load? Anybody can tell me where? I'm talking about maximum negative MA. Anybody can tell me where can I put the value of dead load, which is 0.2 kb per foot? Where can I put the dead load values to get the maximum negative MA? Here is the diagram for MA, influence line for MA. Where can I put dead load to get the maximum negative? Any answer? Do you think I can put it here between A and C? Or between C and D? Or what is the choice for dead load 0.2 kb per foot? Thank you. You don't need to think for dead load. No choice for dead load. Your value of dead load must cover the whole beam or the whole bridge. No choice. For live load, we have a choice. The value of live load here is 0.3. Can you tell me where can I put the live load value to get maximum negative? The problem is asking for maximum negative only. So I believe for live load, To get the maximum negative, I will put it here only. .3 kb per foot between A and C only. This position for live fluid can give you maximum negative effect. Okay, we need value. What is the value? M A maximum negative value equal value of dead load time the area of this diagram, because your value covering the whole beam. So this area will be negative 1/2 times 20 times 10. 20 is this distance. 10 is this one, 1/2 because it's a triangle, plus the other area positive 1/2 times 10 times 10. Plus, this is the value of dead load, plus value of live load 0.2 time. What is the area covered by live load only? This area only. So we have negative 1/2 times 20 times 10. What about this one? We don't have value. We don't have live load. So that's it. Go ahead and find your number. Negative 0.5 times 20 times 10 plus 0.5 times 10 times 10 times 0.2. 0.2 times 0.5 times 20 times 10. Your final value will be negative 30 kb foot. For this bridge, under the effect of this dead load and the live load, in the worst case, the maximum negative value for MA will be negative 30. The worst case, under the effect of this dead load and the live load, the worst case for maximum negative moment at A will be negative 30. One more time. Let me do it one more time for the second one. We are looking for maximum positive reaction at C. Maximum positive reaction at C. Can you remind me what was the reaction of YC? Yeah, the reaction of YC was something like this. 0 here, and your diagram looks like this. And this value was 1, this value was 2. This one. So please keep your eye on the diagram on Fluence line of YA. Where is the dead load? Where is the live load? If you are talking about dead load, please don't think about anything. Don't say anything about the dead load because we don't have a choice. The dead load must cover the whole beam. 0.2 kb per foot. For live load, okay, we need to look to the diagram. We are looking for maximum positive. Maximum positive. We have this diagram which is positive, so I will put the live load only under the positive diagram. 0.3 kb per foot. Can you tell me what is the value of reaction YC which is maximum positive? Yeah, I can. Equal the value of dead load 0.2 time. What is the area do you have? We have this area which is positive 1/2 times 20 times 2. Do you have any other area? No. Plus the value of live load 0.3 times this area also 1/2 times 20 times 2. Then I can get the value of maximum positive. the worst case for reaction Y, this is YC, I'm sorry, YC. So 0.5 times 20 times 2 times, this one will be 10 kip. So just a reminder, once you set up where can I put the dead load and the live load to get the maximum effect, then the dead load value will be multiplied by area of diagram plus live load time area of diagram. Which area here? The area of diagram covered by dead load. In our case, the dead load covering the whole beam, so the whole diagram. Live load time area of diagram. Which diagram? The diagram covered by live load only. If you are talking about maximum positive, I will multiply by this area only. If you are talking about maximum negative, I will multiply by this diagram only. So for live load, we have a choice. For dead load, we don't have choice. Okay, we can do one more. If we are looking for maximum negative effect for YA. Can you remind me what was the influence line for YA? I think influence line for YA was something like this. This one is 1, 1, and 1, positive, negative. Can you go back? This is the influence line for YA. Okay. We need to figure out where can I put the dead load, where can I put the live load, and then can you tell me what is the maximum positive YA equal how much? Any help? Where is the dead load distribution? No choice. Don't try to think. For dead load, I don't care, positive or negative. I'm sorry, we are looking for maximum negative. I don't care positive or negative. I don't care what is the shape of the diagram. I don't care about anything because I don't have a choice. For dead load, must cover the whole beam. No choice. Don't try to think. For live load, no, we have choice. What you are looking for, I'm looking for maximum negative. And your diagram has positive diagram and negative diagram. Can you tell me where is the position of live load to get maximum negative? Okay, I will put my live load only under the negative diagram. Only. Okay, what is the value? What is the final value? Okay, dead load time the area of diagram covered by this dead load, the whole area, whatever positive or negative, I don't care because your dead load covering everything. So we have positive 1/2 time. I'm sorry. Wait. This area of rectangle will be 1 times 10 plus this area of triangle will be 1/2 positive also, 1/2 times 10 times 1 plus this area of negative diagram will be negative 1/2 times 10 times 1 plus this is for dead load plus live load 0.3 time only area of diagram related to this position only, negative 1/2 times 10 times 1. What is the final value? I think this one, wait, this one will cancel this one. So we have 0.2 times 10, 0.3 times 0.5 times 10. You will have 0.5. Okay. I don't care what is the final value. The final value positive or negative, I don't care. I don't care. I know you are talking about negative effect, but your final value is positive. I don't care. That means we don't have negative effect or maximum negative effect on YA. I don't care. So how can I figure out where can I put the dead load? Where can I put the live load? It's very easy. Based on the diagram. For dead load, no choice. For live load, no. We have to follow the diagram you draw. Any question so far? Any question so far? Okay, let me do another example. Example number 3. We need to draw influence line for reactions YA and YB. Please read your problem carefully. Don't miss anything. Don't miss anything. So influence line for YA, influence line for YB, and we need to figure out what is the influence line of shear at C, moment at C. So influence line for shear at C, influence line for moment at C. This is the first part of the problem. We need to draw influence line for reactions YA, YB, shear at C, and the moment at C. This is the first part. Let's start. Let's focus on this part first. We have a beam A, B, A is roller, B is hinge, nothing else. We don't have fixed, we don't have pin connection, we don't have anything else. So it's very simple. If you would like to draw influence line for YA, go ahead and push this support up by 1. Any other support as it is. The new shape of this beam looks like this. Very simple. This value will be 0.5. This value will be 1.5. Using triangle similarity. Please look for any two triangles which are similar. Then you can figure out these values. What is the influence line for YB? Go ahead and put this support up by 1. Any other support as it is. The new shape of this beam looks like this. This value will be 0.5 negative. This one will be 1.5 positive. This one negative, this one positive. If you would like to draw influence line for shear and the moment at point C, I have to go back to our trip. If you have a car moving on this bridge, I will assume this side is D, this side is E. So the truck will move from D to E, the beginning of the bridge to the end. But because we have point C in between, this point C cut your trip to 2 parts. The first part from D to C, this is the first trip. The second trip from C to E. So let's start with the first trip. Your truck is moving on this side of the bridge. I don't like this side. I hate it. So I will decide to use the other side. The other side I did cut here. We have reaction here called YB. This distance equals 6 feet. At your cut, we have shear would like to rotate this part clockwise direction, VC. And I have moment would like to make this part to smile, MC. If you apply summation f of y equals 0, I can say VC equal negative YB. If you take moment at C at this cut, assume this direction is positive, I can say MC will equal 6 YB. Second trip. If the second trip started, right now your car or your truck is moving on the other part from C to E. I hate this part. I don't like it. So I will do my cut and use the first part. We have reaction here, YA. I'm going to assume my shear to rotate this part clockwise, VC, and my moment to make this part to smile. Here is point C. If you apply summation f of y equals 0, I can say VC equal YA. If you apply summation moment at C equals 0 and assume this direction is positive, MC will equal YA times 6, because this distance is 6. Based on these calculations, I can set up the diagram for VC and MC. Do you remember that? Okay, let me remind you. From D to C, I'm looking for YB and multiply it by negative. From D to C, here is YB, this diagram. Can you take it and multiply it by negative? If you multiply this diagram by negative, the negative will be positive, the positive will be negative. It will look like this. From C to E, from C to E, I will look for YA, this diagram. Can you take this diagram as it is without negative, without any change, to put it here? It will be looks like this. This value will be 0.5, this value will be 0.5, because this value is 0.5, and this one will be 0.5. This diagram can be called influence line for shear at C. If you would like to draw influence line for MC, okay. From D to C, we are looking for YB times 6. YB, this diagram, times 6. Positive or negative? No, I didn't change any. So this diagram will be the same. The positive will be positive, the negative will be negative. But this value 0.5 times 6 will be 3. This value 0.5 times 6 will be 3. Negative and positive. From C to E, I'm looking for YA times 6. Here is YA times 6 will be like this, will be 3 and 3. The positive will remain positive, the negative will remain negative. Here is influence line for MC. So the first part of this problem, we need to draw influence line for reactions, influence line for shear at C, influence line for moment at C. I am done. And we cover this example one time before. The second part, if you have dead load equal 0.3 and you have live load equal 0.5, can you tell me what is the maximum positive moment at C? What is the maximum negative shear at C? Let's start with maximum positive moment at C. Maximum positive moment at C. First of all, can you remind me what was the influence line? For moment at C? Yeah, influence line for moment at C was something like this. Negative, positive, negative, 3, 3, 3. Can you remember? Here you go. This one, influence line for moment at C. Okay, we have dead load and we have live load. Can you tell me where can I put the dead load and where can I put the live load to get the maximum positive effect? Please don't think about dead load, because I don't have a choice. Your dead load must cover the whole beam. What is the value of dead load? Is given 0.3. Yep, perfect. What about live load? No, for live load we have a choice. Okay, tell me where can I put the live load? You would like to get the maximum positive? Okay, I will put the live load here only. That makes sense? 0.5 kb per foot. Okay, what is the value of MC, which is maximum positive? The value of dead load, 0.3, time area of the whole diagram. We have this triangle, which is negative 1/2 time. This length is 6 feet, so times 6 times 3. I can multiply it by 2 because we have another triangle on the other side, which is negative. Plus area of this triangle, which is positive 1/2 times 12 times 3. Plus value of live load, 0.5, time. What is the diagram covered by this live load only? This positive diagram. 1/2 positive time 12 times 3. I can get the final answer will be negative 0.5 times 6 times 3 times 2 plus 0.5 times 12 times 3. You are lucky. This one will be 0. 0.5 times 12 times 3 times 0.5. This value will be positive 9 kb per foot. Okay. This is the maximum positive moment at sea. What about maximum negative shear at sea? Okay, can you remind me what was the maximum as the influence line for shear at sea? Your influence line was something like this. Point five. That's right. This is the influence line for shear at sea. Yes, this diagram. Can you tell me where can I put the dead load? Where can I put the live load? For dead load, we don't have a choice. The dead load must cover the whole beam. For dead load, 0.3 kb per foot. What about live load? Wait a moment. You have to go back to the problem. We are looking for maximum negative shear. We are looking for maximum negative. So where can I put the live load? At this location and this location. That makes sense. Only under the diagram, the negative diagram. This one is positive. I'm sorry. This one is negative. Sorry. So at this location for negative diagram. What is the final value? Shear at sea, maximum negative. Okay. The value of dead load time the whole area covered by dead load, the whole area, the whole diagram. So we have positive 1/2 times 6 times 0.5. I will multiply it by 2 because we have two diagrams. Plus negative 1/2 times 6 times 0.5 times 2 because we have two diagrams. Value of live, this one is 0.5. Value of live load 0.5 time this diagram, negative 1/2 times 6 times 0.5. The other diagram will be the same value, so I will multiply it by 2. This term will be 0. This one will be negative 1.5 kb. So finally, I have bridge. I can draw influence line for reactions, influence line for shear, influence line for moment at point C. This bridge has live load equal 0.5 kb per foot, has dead load equal 0.3 kb per foot. Where can I put the distribution of dead load and the live load to get maximum positive effect at C, moment at C, maximum negative shear at C? Okay, based on this diagram that you draw, I can figure out for dead and live. For dead, I don't have a choice. For live, if you are looking for maximum positive, I will put the live load only under the positive diagram. If you are looking for maximum negative, okay, I don't have a choice for dead load, but for live load, I will put only live load under the negative diagram. If you would like to get the maximum value, the final value, okay, go ahead and multiply the dead load value by the area of the diagram covered by this dead load. The live load value by the area of the diagram covered by this live load. Looks good? So based on the previous week, we covered if we have dead load and live load distributed load. What will happen if you have truck? Do you think the truck will be uniform distributed load? I don't think so, because the contact between any truck and any bridge through this wheel, and this wheel. So we will have concentrated load. What is the case if you have a truck? We will cover it next meeting. By the way, for live load as a distributed load, looks like people crossing the bridge. Sometimes we have pedestrian bridge. So if you have uniform distributed load called live load, so we have people crossing the bridge. So the live load in this case will be distributed, and that makes sense. But if you have truck crossing the bridge, in this case, the live load will be represented by series of concentrated load. And this is the case next meeting. Before leaving, anybody has any question? Anybody has any question? Next meeting will be the last meeting for this topic, influence line. Please go ahead and start to study this topic. Don't wait anymore. Train yourself to sketch. Can you see? Can you see this example? Train yourself to sketch influence line for reaction. Without influence line of reactions, you cannot complete this kind of problems. Reaction, reaction, reaction. For this example, we started first with reaction YA, reaction YB. Based on these reactions, I can derive V shear at C and the moment at C. Based on these influence line diagrams, I can set up where can I put dead load and live load. And then I can do my calculation. Okay? Next meeting, I will go through the first example in our in this week's module. But in this case, we have truck, real truck on this bridge. What will happen? We will see.